If you had looked at the sun on September 1, 1859, its activity would have caught your attention. He was at the end of a decade-long cycle during which he was most active. Fortunately, an astronomer named Richard Carrington was observing the surface of our star when it suddenly exploded. In the blink of an eye, a column of plasma larger than Earth separates from the sun, launching high-energy particles into space, traveling at thousands of kilometers per second. 17 hours and 40 minutes later, the particles reached Earth and triggered the largest geomagnetic storm ever recorded in history. When particles from the sun reach Earth, most of them are protons and electrons, moving at very high speeds, and their impact on Earth's magnetic field is significant. The most intense auroras ever observed light up the night. They can even be observed in places far from the poles. There are records of people using aurora lights on the streets and in large cities to read newspapers. But although auroras are beautiful and dazzling, their real effects are invisible. The sun's charged particles are guided by the Earth's magnetic field, which is constantly changing. In the ground, this changing magnetic field induces electrical currents in anything that can conduct electrons. At the time, humans were still in the infancy of electricity, but we can understand its impact by looking at the history of the telegraph operator. The most notable is the line operator that connects Boston and Portland. Please disconnect the battery for 15 minutes. Okay, we're connected. Me too. We only study auroral currents. How is the quality? Better than taking batteries. Communication between the two operators lasted 2 hours without batteries connected. In other areas, telegraph lines simply stopped working, electrocuting operators and sparking transmission towers. This storm became known as the Carrington Event. If this were to happen again today, many researchers believe our entire technological fabric would be coming to an end. To make matters worse, this year we are once again in the middle of the most active solar period, just like in 1859. This news is circulating all over social media, and some of them even claim that a new Carrington event will occur this year. A new despair emerged and the fear of a return to a pre-technological civilization shook even the most hopeful. But how realistic is this idea? Whenever you hear about solar storms, it's important to understand exactly what we're talking about. Probably the two most famous solar storms are solar flares and coronal mass ejections. To understand how they happen, you can imagine the sun as a furry ball. The hair you see in the image represents the magnetic field lines of our star. These lines are always moving and changing location. Sol is a very busy place. Solar flares occur when magnetic energy builds up on the sun's surface and is quickly released. What we see from Earth are flashes of electromagnetic radiation. And it is quite common, but not always the case, for these eruptions to be accompanied by coronal mass ejections, which is when an intense magnetic field line is ejected from the sun along with plasma, formed by charged particles. These particles, which are basically protons and electrons, are launched into space at very high speeds, reaching 3,000 kilometers per second. And it is these coronal mass ejections that are responsible for most geomagnetic storms and auroras, like the one that happened in 1859. The scary part is that we have no way of predicting when exactly they will happen. The sun works in cycles of activity that last around 11 years. And in the meantime, our star's activity increases, reaches a maximum, and then decreases. We can get an idea of where we are in the cycle by looking at the number of sunspots on the sun's surface. The more spots, the more active the sun is. And as expected, solar flares are more frequent during periods when solar activity is greater. During periods of maximum activity, solar flares occur every day. And during periods of low activity, it happens about one a week. But we don't understand solar dynamics well enough to predict when exactly the minimums and maximums will be reached. We only know that cycles last an average of 11 years, based on more than a century of observations. And we are now at what we imagine to be the peak of the current cycle. If I were you, I would even subscribe to the channel here after this, and it helps me a lot. Okay, but what exactly will happen to Earth if it is hit by a coronal mass ejection? The particles ejected by the Sun are the same as those that make up our star, that is, plasma. This means that the atomic nuclei were separated from the electrons, becoming free electrical charges. And, in addition to electrical charges, the coronal mass ejection also takes with it some of the Sun's magnetic field. When these particles encounter the Earth's magnetic field, it is as if they compress it, changing the configuration of the field that protects our planet. Then, from one moment to the next, an immense amount of energy is deposited in the Earth's magnetosphere, and with it come the consequences, which depend greatly on the severity of the storm. A light geomagnetic storm can create just auroras, without attracting much attention and filling the news. Here on the surface we are relatively safe, both by the Earth's magnetic field and the atmosphere. But every now and then, a stronger solar flare creates bigger consequences, particularly in space. Satellites in orbit can become electrically charged and burn out important components, stopping them from working. Or, in even worse cases, the solar storm, together with ultraviolet radiation, heats the outer layers of the atmosphere, causing it to expand. From one moment to the next, satellites are affected by more drag from the atmosphere, which can even take them out of orbit. And this was one of the reasons why Skylab, which was the first American space station, re-entered the Earth's atmosphere faster than expected, ending the program that later gave way to the International Space Station. This was also what happened in February 2022, with 40 Starlink satellites that had recently been placed in orbit. They were unable to overcome the drag of the atmosphere and re-entered Earth. A loss in the order of millions of dollars. But even systems on Earth are affected by changes in space. Solar storms change the density of the ionosphere, which is one of the furthest layers of the atmosphere. Several of our communication systems use it to reflect radio signals and reach long distances. When it is disturbed, signals vary unsteadily and communication is lost. In other words, a radio blackout can happen on some frequencies. And since during such a storm the Earth's magnetosphere is full of charged particles, electrical currents can be induced in the ground. This happened in March 1989 and the result was that the electrical grid in the province of Quebec, in Canada, failed because it could not handle the electrical currents induced in it. The result was an entire province that was home to millions of people without power for a few hours. The economic loss was estimated at a few $100 million, and this storm was not nearly as intense as the Carrington event. This brings us back to the question that led to this video. Could a Carrington event happen this year? The honest answer is maybe. Nobody knows for sure. And anyone or news that says otherwise is lying. Our understanding of the Sun does not yet allow us to accurately predict when solar flares or coronal mass ejections will occur. In fact, we now know that solar flares with the same intensity as the one that caused the Carrington event can happen even in periods of low solar activity. The truth is that it is impossible to predict. It could literally happen right now. And in fact, one almost happened a few years ago. In July 2012, the Sun suffered one of the largest coronal mass ejections ever recorded. She missed Earth for 9 days. If it had happened a week earlier, it would have hit our planet hard. The intensity of the geomagnetic storm that this coronal mass ejection would generate would be comparable to the Carrington event of 1859. We literally hung on by a thread. Some prevention studies carried out later indicated that if it had hit us hard, it would have taken us 4 to 10 years to rebuild all the infrastructure that would have been lost. A loss that is even difficult to imagine. We often hear of loss as a cash equivalent. Oh, it was a total of trillions of dollars, billions of dollars. But we never stop to think about the impact an event would need to have for us to need to measure the damage in years. In the end, we have no way of knowing when the next Carrington event will take place. But we'll have a window of a few hours before it hits us. Humans will not be affected biologically. We are protected by both the atmosphere and the Earth's magnetic field, but we will certainly feel the technological impacts. Look around you and try to pay attention to the number of things that need electricity or electronic circuits to function. Now imagine life without them, at least for a while until we fix everything. What would you miss most? Tell me here in the comments. I'm very curious to know. And if you like this type of video, don't forget to subscribe to the channel to always know when we post a new one. Thank you very much and see you next time.